I'm Monishmani P of URK25CS1080. This is my practicum number 3, address calculation using addressing modes. There are totally 8 addressing modes: direct, indirect, indexed, base, plus index. There are totally 8 addressing modes in which we are going to see all, and also its execution. And we are going to find actually the effective address, memory access, and the execution time, and the execution speed, and the power consumption of each addressing methods in this. So first we have to start by clearing the window, and we are using the while loop to loop it n number of times until the user chooses exit. So the menu of addressing modes, addressing, immediate addressing, register addressing, direct addressing, indirect addressing, indexed addressing, displacement addressing, base plus index plus displacement addressing, scaled index addressing, PC relative addressing, stack addressing. Totally here we are going to deal with 10 addressing modes. So first we want to enter choice. We are getting the choice of the user, and then if the choice is 0, the program is ended with the break statement. Else not. Here is the switch case for it. Immediate addressing selected, and enter the immediate operand value. So as it is immediate addressing, the effective address is not applicable, and the memory access is also not needed, but the time is started and the time is completed here. Tick and talk. Then register addressing, a register value is asked here, but effective addressing is not needed, and memory access is also not needed, as this requires no memory. Here is the direct addressing mode, in which the address of the memory address is taken, and the effective address is equal to the memory address, the memory access is equal to 1, and the execution time is equal to talk. So we are starting the time with tick and completing time with talk. So here is the indirect addressing, the pointer value, address obtained from the memory. So where it is stored, we are getting that pointer value, and then effective address is calculated with that, and the memory access is equal to 2, as it requires 2 memory accesses. Then the execution time is completed. Indexed addressing, we get the base address and the indexed value. EA is calculated with base address plus indexed value, and memory access is equal to 1, and the execution time is completed here. So this is the displacement addressing mode. In this we get the displacement and base address. So base address plus displacement is equal to EA of this operation, and memory access is equal to 1, and the execution time is closed. Base index plus displacement. So in this addressing mode, all three values are added for the effective addressing, and the memory access is equal to 1, and the execution time is also closed. Then scaled index addressing, in which we get base, index, and instead of the displacement value we get the scale factor, and then we calculate the effective address by base plus index into scale. The memory access is equal to 1, and the execution time is equal to talk. Then PC relative addressing, in which we enter the PC value and enter the offset value. Effective address is calculated by PC plus offset. Then stack addressing. This is the last addressing mode that we are going to encounter here. Enter the stack pointer value, then stack pointer value -1, pre-decrement stack, and the memory access is equal to 1, and execution time is equal to talk. If all the options are not chose, if the user gives any other choice, it will give invalid choice, and please select a valid option, and it will continue the loop. So performance classification is also given. If memory access is equal to 0, execution speed is equal to fast. If memory access is equal to 1, the memory access is equal to if 1, execution speed is equal to moderate and power is more. Else execution speed is equal to slow, more power. So the results are displayed here. Here is the sample output table mode. Operand is equal to 25. The effective addressing not applicable. Register R1 is equal to 500 not applicable. Register 1200. Direct addressing address 200. the effective address is 1200, indirect pointer value is equal to 1500. Here we get 1500, indexed we get base value 1000, index value 20, so 1020. The base plus index plus displacement is equal to base plus index and displacement values are given, so 1024. Scaled index value, base index plus scale is 1012. So by adding this, we will get 2012. We get by adding this. Then PC relative, PC plus offset. So 5000 plus minus 10, 4990. Stack value is also given. So as it is pre-decrement, 3000 minus 1 is equal to 299. Then the following results are obtained. Thank you.